Hey guys, welcome to third part of this tutorial, and this particular section we're dealing with numbers and operators. So try to recognize these numbers in three forms. That's the integer, the float, and the complex number. So the integers just deal with whole numbers, the float deal with decimal numbers, and the complex deals with imaginary numbers. So the first operator we're looking at here is an arithmetic operator, and this includes your regular operators in arithmetic: addition, subtraction, division, multiplication. So the only thing new here is your modulus, floor division, and exponent. So for this tutorial, I'll be using the Jupyter notebook. So this is interface of your notebook. Since you are starting out, I'll suggest you use PyCharm. I'm going to drop the link in the description. So PyCharm is an IDE. That's IDE is integrated development environment that help you to code faster. So there are two versions. We have the professional and the free community version. So the community version is free of charge, but the professional charges a fee. You can download it and straightforward to install. But for the speed I need in tutorial, I'll be using my Jupyter notebook. So we want to look at arithmetic operators. Now what do we have in arithmetic operation? We have what? Addition, subtraction, division, multiplication, exponents. We have the modulus, and we have the floor division. Okay. So let's define some numbers. Let's say a is equal to 10 and b is equal to 5. Okay, so if you look at addition, which is what a plus b, so if you run this, a plus b, so if you run this, I guess now output will be what 15. That's a plus b. So if I do a minus b, that's 10 minus 5. I'm having what 5 as my output. So I can do what a divided by b. I got 2. That's 10 divided by 5, 2. And I can do my a multiplied by b. And that's all of 50. That's 10 times 5, 50. So for the second, the other ones, we have the exponent. Exponent is just raising to power. So I can tell you that 2 exponent 2, that's 2 raised to power 2. If you run that, we have what 4. Okay. So I can take another one, maybe 3 raised to power 5. That's 243. Okay. So we have what our modulus. Modulus is just to get the remainder of any division. So if I do something like 5 modulus 2. So if I divide 5 by 2, what's going to be my remainder? Is remainder 1. That's 5 divided by 2 is 2, remainder 1. So it's the one that gives an output in modulus. To get the remainder of a division. If I do 4 modulus 2, we are getting 0. That's 4 divided by 2. There's no remainder, is 0. So that's what your modulus will do for you. And we have the floor division. So in modulus, you get the remainder and forget the actual division integer. But now if I want to get the real division and forget the remainder, so if I do 5 plus 2, we're having 2 what, but it's not showing the remainder. So that's what your floor does, just give you the whole number and forget the remainder. So if you do 4 plus 2 also here, find out what the answer is was 2. It doesn't consider what the remainder. So that's it about arithmetic operators. So let's go to the next type of operators. We have the relational operators. So what the relational operators just actually handle is it compares what's on the left and right hand side and give you either true or false as your answer. So back to our Jupyter notebook. Okay. So let's say I define x equal to 5 y equal to 7. Okay, y equal to 7. Now I want to check, is x greater than y? So what's x? X is 5, y is 7. So I want to check which one is x greater than y. So it's giving us false because 5 is not greater than 7. So I can now do what? Okay, is x less than y? True, because 5 is less than 7. So I can also ask, is x equal to y? False, because 5 is not equal to 7. So also have things like, is x greater than or equal to y? Is false because 5 is not greater than or equal to y. But if I do x, is x less than or equal to y? True, because 5 is less than y. So to check one of the conditions. So that's it about relational operators. So next kind of operator we'll be dealing with is the assignment operator. So it is used to assign value. Your single equal to is an assignment operator, but double equal to is for comparison. So we have the one that used to increment, decrement, multiply. Let's see examples to understand this better. Okay. Let's say I define x equal to 5. We have x equal to 5. So I want to increment 5 by 2. Let's now get the value of x. What is the new value of x? Is 7. Now, what happened here? This is simply what happened. In fact, this is another way of writing it. I could have written it this way. So it picked the initial value of y, of yx, which is 5, and added 2 to it. That's why we are getting 7. Like if I come here and say x is equal to x plus 2. Okay, so let's run that. So let's get the value of x now. And you see x is what? X is 11. Picking, it has incremented this twice. It picked it as, because I ran it twice, so it's giving me 11, 13. If I do it again, if I come back to the same cell again and do that again, 15. So we keep increasing it by what? By a constant of 2. And you could do the same thing for the subtraction. So if I define y to be 7, for example, and I say y is equal to y plus 5. So if I attempt to get the new value of y now, so we're getting 12. That's 7 plus 5 is 12. So if you run again, so if you call y again here, you still get the same what? You still get the same 12. So it's useful we'll soon get to loops. It's useful when you want to increase a particular number by a constant. That's the usefulness. So you could do the same thing for subtraction. You could do the same thing for subtraction. So that 7 minus 5 is giving us what? 2. You could do the same thing for multiplication. So it will be 7 times 5, 35. Okay. So that's all about the assignment operator. So let's check the next part of operator. Okay, so in this logical operators, we have 3 types of logical operators. That's the and, or, and the not. So what this and do is this: it will check if both operands are true and return a true. If one of the operands is true when using the and statement, is going to return a false. If one of the operands are false, if one of the values are false, it's going to return a false as the answer. Now for the or, If you consider if at least one of them is true, it will give you a true. So even if one of them is false, it will still give you a true. While the not is just an inverter, it will invert the actual value you have there. So let's move on to our Jupyter notebook. Take an example. So if I declare A to be true and B to be false, and B to be false. So now if I say A and B, so let's run A and B is false because B is false. Once one of them is false, it's going to give you a false. So if you change B to be true, now that's both A and B are true. We are getting what? A true as the answer. So let's return this back to false. So if you do that again, you are getting what? A false because we did A and B. So if one of them is false, it's going to return a false. So if I say A or B, now one of them is true, one of them is false, it's going to return a true because it's A or this, just like a normal English, this or this. So once one of the part of the statement is true, the statement is considered to be true. Then when you use your not is just an inverter. So if I say not A, so the actual value of A is what? The actual value of A is true. So if you say not A is false. Now the actual value of B is false. If you say not B, it return what? True. So that's it about the logical operator. It's very simple to grab. Then we have the bitwise operator, or we can call it the binary operator. So we have the bitwise and bitwise or bitwise not. So it's just about binary operation. So if I say 2 and 5, so let's run that. Okay, it's giving us 0 because it did a binary operation on 2. Python has an easy way of getting the binary of any number. So if I do the binary of 2, bin 2 is giving what? It converted to hexadecimal outputs, bin 2, and if I say bin 5, so it's not an a binary output, that is 2 is 1 0 in binary. So we do bin 5, so 101. So when you multiply these two, it's going to give you 0. If you do 6 and let's say 6 and 4, it's giving us what? 4. So it did the operation in binary and returned it back to decimal. So you can do your normal binary addition. So you want to convert the addition. So that's 4 or 4. That's 4 plus 4 in binary. It's going to give you a 4 again. So that's the bitwise operator is used to carry out binary operations basically. So you also have what? The not. So if I do not 4, so not 4 give what? Minus 5. That is this 4 complement is a complement of 4 in binary. So it gives us what? Minus 5. So it did the operation in binary and converted back to decimal. So this will be the end of the tutorial on operators.